All right, this is the last section in Chapter 6. We're going to basically solve parametric equations. It's a little bit different. We're going to talk about eliminating the parameter. So what we're going to want to do is any equation that you get, we're going to want to actually solve it for cosine and solve it for sine, because we know that cosine is the x and sine is the y. And what we're going to do is we're going to end up plugging these things into one of our Pythagorean identities, and we're going to end up making either ellipses or hyperbolas. So we're going to go back to some conic sections, and we're going to draw these things, and I'm going to kind of help you figure all that fun stuff out. So before you do anything with any equation that you want to do, you do need to eliminate the variables. So you're going to want to get your trig functions to be lined up all by themselves. So if you look at the top one, how do you get the trig function all by itself? You must divide by 3. So I know that cosine t equals x over 3. And do the same thing for sine t. So you're going to want to divide by 2. And I know that's going to be y over 2. Now why do I want to do that? Now what we're going to do is we need to go to an identity that involves sines and cosines. Okay? Well, I know that sine squared t plus cosine squared t equals 1. Okay? And what this ends up being is your ellipse equation. It might have been a while if you've done this since Algebra 2 or things like that, but I will kind of help you in a crash course per se, dump this in. So if I go sine squared t and substitute y over 2 in, it's going to be y over 2 squared plus cosine squared is x over 3 squared. That equals 1. And if I multiply or essentially distribute the square out, I get y squared over 4 plus x squared over 9 equals 1. And this is an ellipse equation. And how this works is, I'm going to even write this up here in case it would mess with you a little bit. X minus h squared over your a squared actually, plus y minus k squared over b squared is 1. Okay. Now, we don't have an h or a k. There's nothing added or subtracted these things. And your h or k is your center, your middle of the ellipse or circle, depending upon kind of the scenario. But in this case, it'll always be an ellipse. All right. The bottom, all right, is going to be the b value. Now, this is technically squared on the bottom, so you have to take the square root of 9, which is 3. You're going to be 3 units on the x-axis in each direction. Okay. An ellipse is going to essentially look like a football. So you're 3 units each way there. And then your y value is 2 units on the y-axis, or in this case, square root of 4 is 2. 2 each way. And then you connect your dots. This is your ellipse. This equation will make that type of picture when we change the parameters. So we went from saying, okay, the x is some trig function, the y is some trig function. To eliminate the parameters means we're taking the cosine and sine out of it, putting it into a Pythagorean identity, and then making an ellipse out of it. Okay? So that is going to be your sines and cosines will make ellipses, essentially. So let's get a little bit more difficult. Once again, solve for your trig function. So in this case, I'm going to need to subtract 3. So in this case, I know that sine t equals x minus 3. Okay, I'm going to have to add the 2. So I know that cosine t equals y plus 2. And if I put this back into my Pythagorean identity again, sine squared t plus cosine squared t equals 1. I'm going to dump it in and square it. So I need to go x minus 3 squared plus, what do I got here? What's the y? Here's the y. So it's going to, the cosine is going to be y plus 2 squared. That equals 1. Now what's under it? They're both technically 1. So this isn't an ellipse. This technically is a circle. And you guys might recognize that as a circle. And what are we going to do? Where's our center? So if I go back to my little formula I drew here last time, remember it's going to be opposite signs. No different than when we graph trig functions, when you guys went back to graphing stuff in Algebra 2. It's the h and the k, but it's opposite signs inside. So your center, your middle, is going to be a 3, a positive 3. And since I changed to plus, it's going to be a negative 2. So the middle of this thing is going to be 3 over to the right and 2 down. There's your middle. And then how far do I go each direction? Okay? It's the numbers that are under here. And technically they're squared. Square root of 1 is still 1. So you're going to go 1 unit in every single direction. Okay? 1 unit here, 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 and here. And that's technically the graph that it drew. Okay? So that's kind of how that works. Now this is the most difficult one on the next page. It's secants and tangents. So first of all, you can still solve for your trig function. That doesn't change anything. So in order to do this, I have to what? Subtract 3 and then divide by 2. Okay? So my secant t will be equal to x minus 3, and then I divide that all by 2. Likewise, to get tangent all by itself, you will subtract 2 and then divide by 4. So tangent t would be y minus 2 over 4. So now I'm tying everything together, and I'm giving you a different trig function, so that's kind of mean. Okay. Tangents and secants. If you guys look at your salmon sheet in the top right corner, you guys notice that you got tangent squared theta plus 1 equals secant squared theta. Now in order to do this, we actually need to get the trig functions together on the same side. Okay? So I'm going to want to have the 1 all alone, so I'm going to subtract the tangent. So the best thing to do would be 1 equals the secant squared theta minus tangent squared theta. So I just subtract this one over. I want to put these together. This is going to make it a hyperbola type scenario once we eliminate the parameter. That's what I'm going to do now. We are now going to dump this guy in for the secant, dump this guy in for the tangent. And you're going to have to square them both. So let's do that now. We're going to go 1 equals. What is secant? It's going to be x minus 3 over 2 squared minus, I'm going to put this y minus 2 over 4 in for tangent. Y minus 2 over 4 squared. So if I multiply this out, 1 equals x minus 3 squared over 4 minus y minus 2 squared over 16. So this is actually the formula you will need to give me to earn full credit. And then the fun part is trying to sketch this thing. Okay, hyperbolas. I don't know how many of you remember that, but your center, your middle, okay, will end up being what? 3, 2. So I know my center is at 3, 2. So 3 over 2 up. That's my middle of what's going to end up being the box, instead of, because a hyperbola is your ellipse turned the other way. It turns into 2 parabolas going away from each other. What we need to try to do is build the box in there. And how do I figure that out? Okay, this 2 on the bottom, which turns to a 4 when you square, but you got to go back to the original one. You're going to go 2 units on the x direction, each way from the middle. So 2 units this way, 2 units that way. Okay, the y value, it says it's 16 on the bottom, square root of 16 is 4. This 4 down here, you're going to go 4 units in the y direction each way. Now what you can do is, I like making this into a nice rectangle. Okay, why does this rectangle help me? This rectangle gives you asymptotes. On hyperbolas, asymptotes, I don't know how many of you remember this, are your diagonals. Okay? So my asymptotes are the diagonals of that box. And your hyperbola will go in the direction of whichever one comes first, because order does matter in subtraction. So the x value trumps. You're going to have this thing go around the x-axis. So here's the only spot it hits your rectangle here. And it's going to go towards your asymptote, but never touch it. And it's going around the x-axis. So that's why it's opening around the x-axis. And they're going to open away from each other. So the trick of graphing a hyperbola is to get your center. All right? Take the numbers that are under them to make this box. The box becomes your asymptotes. And then it opens around the x-axis this time because the x is first. Okay? If it would be the other way where the tangent was first or the y value was here, if the y value was first, these things would open up and down. But they're always going to open in the opposite direction. So that is eliminating the parameter. We will definitely go through a lot more of these in class. And once again, I hope you all have a wonderful day.